Hello all, today in this video I'm going to make an demo for convolution neural network, that is improved convolution neural network with Paddy crop classification. So here we are using multi-class, that is we are classifying 10 classes like bacterial leaf blight, then bacterial leaf streak, bacterial panicle blight, then blast, brown spot, dead hot, brownie mildew, pispa, normal, and tumbro. So these are the normal is just the without any paddy disease, and other are the diseases in paddy. So here already we have made a code for CNN, some improved CNN. We have set the data path as train, and we are going to include all the sub folders in that, and then we are just include the label source and also the folder names. Then we are counting that, and in that we are just counting the number of images, plot each and everything in single code, and that is single figure. Then we are declaring the classes for testing and training. Then all the images are set to size 224 into 224 into 3, and we have given 15 layers for this. So the layer description for this code includes image input layer, convolution 2D layer, batch normalization layer, prelude layer, max pooling 2D layer, then again the set of same convolution 2D layer, batch normalization. Prelude is nothing but a predefined ReLU layer. So you may know the details regarding this layer. We have to define this layer manually apart from the other layers like convolution 2D layer, batch normalization layer, etc. Because those layers will be defaultly found in MATLAB, but this layer will not be defaultly found in MATLAB. We have to declare set a class definition for that, and we are calling that layer only. Since in ReLU we are having some issues, so gradient loss issue. So to solve that we are moving to prelude layer. So training we have set, since we are having 10 layers, 10 classes, we are just put those classes as 10 in the fully connected layer. And in the training options we are just using Adam. Then initial learn rate we have set to 3e power minus 4, but as learning rate decreases, we know that the accuracy increases and the loss decreases. So for that we have just used a learn rate drop factor. It will be reducing for every 3 approaches, and this is then to train the network we are using the train network, and to analyze how many networks are there and what are the variables called in that, we are just using the net transfer, and then we are classifying it, and then we are plotting the confusion matrix and also an confusion matrix, that is ROC curve. Then we are displaying the AUC values. So now I am just running the code. This will take some time, nearly the just I'm just passing the code and quitting, and I'm just rerunning it, since because previously I have set to run it for 10 approaches. 10 approaches will take some time, so just I'm moving with 5 approaches. You can just set your approaches time. So based on your time is not a limit, means you can just make it as 10, 20 and all. So since we have defined a layer, this warning message is coming, otherwise it won't display. So now you can see a training progress graph is displayed, and also in the command window, if you see, means you can also see variables. Once the code is going to run, you can see the variables will also display. So in the next code what we will do is we are just going to save this code, the output from this code, and we will make a guy function for paddy leaf disease detection. So this code has got more than 90% accuracy. So once it has run, you may know it. So in the command window, you can notice the values. You can notice that the accuracy is increasing and simultaneously the loss is decreasing. In this code, for every classes I was having nearly 500 images. So totally 500 into 10 classes, so 1000 image, 5000 images. You can notice that the validation accuracy is higher more than the mini batch accuracy. You may know that the validation accuracy should be high more than a mini batch accuracy for a good system. So the next, after running the code, we will make in as a second part. Thank you.